Okay, good day, boys and girls. We're going to look at graphing sine functions and cosine functions. We're going to start today with sine functions. And in order to do that, what I've done is I've set up what I called a theta y table. Instead of an xy table, it's a theta y table. And this graph is actually should be in terms of theta and y. And so what we're going to do in this unit, in this section, is we're going to place these values into a sine function and get y values out. Now, I'm going to use my handy dandy unit circle for this. So with using my handy dandy unit circle, what I notice is that when theta is 0, and remember I'm doing sine, sorry, and sine is always my y value on the unit circle. So at 0, my y value is 0. At pi over 2, my y value is 1. So sine of pi over 2 is 1. Sine of pi, again, going back to my handy dandy table, the sine of pi is 0. The sine of 3 pi over 2, going back to my handy dandy unit circle, the sine of 3 pi over 2 is negative 1. Oh, I don't know why I keep doing that. I don't want to erase it. I want to highlight it. Negative 1. And then 2 pi is the same as 0 because we've gone back to a full circle, so that answer will be 0 as well. So I want you to notice this pattern. We have 0, 1, 0, negative 1, 0. So what does that look like? At 0, 0, so that's x is 0, theta is 0. When x is pi over 2, when theta is pi over 2, y is 1. Now I'm using this because I want you to see a pretty big picture. I'm using that to be 1. Okay, and then at pi, we go back to 0. 3 pi over 2, we go to negative 1. And then at 2 pi, we're back at 0. So knowing what this looks like just from experience, and you will have that same experience, we know that this function, the sine function, goes up, it comes down, and it goes back up. And we say it's periodic, meaning that it will continue this pattern on and on forever. And if we go in the negative direction, we see that it continues this pattern as well. So if I were to graph it in the negative direction, I'll see that it goes, I keep missing that point, it goes here and then here. Okay, so we see that it goes on and on in both directions forever. And it's periodic. So it started at 0, it increased to a maximum, then went through 0 again, it decreased to a minimum, and then it went back through 0. And that's the pattern. It has 4 steps to that pattern. And the reason I just make mention of that because we need to know those 4 steps as we decide its period. All right, so let's look at some interesting facts about the sine function. For the sine function, notice this graph will go on and on forever. It just keeps going on and on in both directions. So if it continues to go on and on, what do we say its domain is? Its domain would be negative infinity to infinity. There's no value of x that I can't put into a sine function and get a value out. But also notice that it has a maximum value. The maximum value is 1, and the minimum value is negative 1. So we say it has a range of negative 1 to 1. Notice I'm putting those in brackets because the negative 1 and 1 are included. The period is the amount of time it takes to complete a cycle. So if we notice, it started at 0. It completed its pattern by going to a maximum, then going to a minimum, and then back to 0 in 2 pi units. So we say that it has a period of 2 pi. And every 2 pi, it will complete that unit. Notice it started at negative 2 pi, and that cycle ended at 0. So it took it 2 pi to go through that entire cycle. Okay,